So now let's look at doing our sine bit. So first of all, we're in main here, so we can just get rid of this little test unit that we created, so just delete it. Now what we'll do is we'll create a circuit here, so we'll put in add circuit, and this in effect will be our top level circuit. So we can call this top level circuit, let's see, we'll call it FPU underscore multiply. Okay, so what we'll do is we'll try and build everything into this top level circuit. So we know we're going to have our register, so we've got our register here. So we'll give this actually a name here, and we'll call this whole thing, we'll call it input. Now I'll make that, click on it, and we'll change it so it's a little bit bigger, so we'll make it maybe A22 and bold. Okay, so this is the input section of our floating point multiplier. So this section here is also going to have our 2 pins, so our input pins here, which is going to be 32-bit input, and it's going to face it east, and we're going to call that input FPU and just underscore X. Okay, and it's 32 bits. Okay, now we're also going to have our other input, which is our Y input. Okay, so we'll move it down a little bit so we can see it. Now, in fact, what we'll do is we'll just try and make it a little bit neat and tidy. So what we'll do is we'll take this here and we'll put it south. Okay, it means we can shift that up 1. That's just a little bit neater and tidier. So this is going to be our X and it's going to be our Y. And we've got our set and enable, so again we've got to go for our tunnels, and we've got our set here, and we'll copy this and we'll have our enable. And we're going to have our output, so we'll just connect these directly to our tunnels because we're going to use those tunnels on this actual level, so we'll keep everything at this top level of hierarchy. So we'll have our tunnel here, and it's going to be our facing west, sorry, and we're going to have our XS, and we'll copy this, and we'll have our YS, Control C, Control V, and this is going to be our 8-bit, and it's going to be our XE, Control C, Control V, and this is going to be our YE, and finally we'll have our 32-bit mantissa. So that's our XM, sorry, 23-bit mantissa. And we'll have our mantissa for our Y, so we'll have our YM. Okay, so that's us got our tunnels, and we're going to use those in this hierarchy. And we're also going to have an input pin, which is going to be a set and an enable, which will be in the next hierarchy up, which we'll be using for our testing hierarchy in effect. So this is going to give us our input pin and we'll go south with this. So it's going to give us our set. And we're going to have our enable. So this is ENA. And we're going to use those in this level as well. So we're going to have a couple of our tunnels. And we can, here we'll go south. That's our set. And we'll have another one which we'll call our enable. So that's us got everything at this level here that we need for our input and to split our input up. There's one other thing that we want to add in, and that is a couple of probes. So if I make a connection up here and a connection along this way, and if you get in here you'll see there's something called a probe. So we'll get the probe and we'll make the probe south. Now it's a lot handier having this probe here because we can have this sitting as, rather than the input here is 32 bits, we can actually have it as hexadecimal. So this here is a hexadecimal for this. So instead of having 32 bits here, we've only got 8 bits for the hex number for this. And this is a lot handier whenever it comes to actually doing the multiplication and testing, if we can actually have the hex number here instead. So Control C, Control V, and we'll face this north. So you can see here that whenever we change the inputs here, it just changes the inputs here in hexadecimal. Okay, so it's just a lot handier. So now we're interested in an output as well. So we'll start off, we'll put an output which is going to be again another pin. So there's a 32-bit pin. We'll put it over here, and again we'll just copy this, and this is going to be an output section. So this is now going to be our output, which we're still to build up, but we know we're going to have an output here, and we know we need to have a pin, and we know it's going to have to be 32 bits, so we'll change the number of bits here to 32, and we'll face this east, and we'll just simply call it, floating point. We'll call it FPU underscore output, and we've got our connection here. So what we want to do is first of all do the sign bit. We've seen before the sign bit was quite straightforward. It was just a matter of using an exclusive OR gate. So we'll copy this here, and this section here is going to be our sign section. I'll just rename this sign. And we're going to use an exclusive OR, so we can head into the gate section here, and you'll see that there's an exclusive OR there, and we'll make it wide, so just make it a bit larger, and it's going to be a 2 input. Well, and there's going to be one of the inputs is going to come from our XS, Control V, and we'll face it east, and the other one's going to be our YS. So these are the sign bits for the X and the Y, and we'll have our output here. So I'll just leave the output there, I'll put it there, and we'll call this one here, again we'll put a a tunnel. I'll face it west, and we'll call this xs dot ys. So in effect this is the multiplication of the x, the input, the sine input for the x and the sine input for the y. So these here have to go up to the sine input for this output here. So this point here will go up to this point here, but in order to get there it's going to have to go through a splitter. So let's go ahead and we'll put the splitter in for this. So we've got a copy of the correct splitter down inside the hierarchy here. So this is the splitter we want here. So we can Control C and we'll head back up to the top level and Control V. So we've got a splitter here. Now we'll just take these out and we're going to face the splitter in the other direction. So we'll take it and we'll make it right-handed. That means our splitter can just head into here, and now we can connect our output XS YS, and we can connect it to the pin here. So we'll face that north. So when this gets connected, we'll see the output here changes. So we'll go down here and we'll just put in, we'll reset the simulation and we'll put enable and the set to go high. So we're passing everything through and we're splitting it up into the X terms and the Y terms. And we're going to test this single pin here. So when X is 0 and Y is 0, that is when both of them are positive, the output is going to be positive. Whenever the value of the X is negative, the output will be negative. Whenever the value of Y is negative, the output will be negative. Whenever the value for X and Y are both negative, the output is going to be positive. So that's us done one little section of our floating point multiplier. We're able to work out the sign of the multiplication. So let's move on in the next video and we'll start building up the exponent section.